Bueno, vamos a dar unos minutos. He visto que estaba lloviendo y que estaba el tema de comer muy complicado, con lo que un poco de paciencia para los que habéis sido puntuales. Muchas gracias por la seriedad. Seguimos investigando el tema de los equipos. Estoy bastante enfadado con el tema. Así que esperemos que esto se resuelva como se tiene que resolver y veremos.
Hola, buenas tardes. Nada, vamos a seguir.
Good afternoon. We're going to continue the presentations for today. And here with us is Juan Manuel Servera, who's going to talk to us about risky things, which are the risks of IoT. Thank you. So my name is Juan Manuel Servera. 2 years ago I worked, well, for about 2 years I've been working at Microsoft. I'm a technical evangelist, and I am to have an interactive session here. I tend to talk a lot, so I hope we'll leave some room and some time for questions. So if you have any questions while I speak, please raise your hand and someone from the team will bring your microphone. So I'm here to talk about the Internet of Things, about the risks embedded. I'm not a security expert, I'm rather in development and the cloud and IoT. When I talk to many customers about how to connect all these devices in our industry, many questions arise. So I'm here to talk about the problems I have encountered, the research I've made, so that you can tell me about your problems and let's see which conclusions we can reach. I'm going to turn this on. And this topic is quite fashionable, IoT. If you read the research, they say that in 2020 there will be 20 billion devices. 20 billion devices connected by 2020. Other research talks about 50 billion. That figure is not as important. We know it will be a lot of devices, and a relatively small percentage, around 35% of them, will be in the entrepreneurial sector. Before I was at Microsoft, I worked at another company dealing with industrial quality management. I started working there about 15 years ago. And at that time, we didn't really care that much about security, at least not as much as nowadays. We didn't care about user privileges and about certain software security, but everything worked in a local network, sometimes even in a factory. That could have been a cream factory or a cutting machine that got the data and assessed them to check the product quality. Those machines connected to a server that maybe was next door. But we didn't connect all these things to the internet. Nowadays, however, we do connect everything we can to the internet. And eventually, the way we manage things and the way we manage all these elements is greatly increased. And that represents many challenges in managing these devices and in the security area of these devices. How can we make all those devices safe and secure? Nowadays there are many companies and many spheres in our life when we're going to apply all that, not just on the industrial side, but also in transport, medicine, and pretty much any area of our life. In fact, many of those IoT devices will be wearables. So which of you have some sort of wristband that collects your data? Or which of you have a smart TV? Many of you. Okay, so which of you have a smart washing machine? Okay, less people, but we will soon have all these things, and we will actually have an explosion of devices that we will need to care about. We need to care about the security of those devices and how to manage them. And since this is quite new, because we did the same thing 15 years ago, but we didn't connect these things to the internet. Now we do connect them to the internet, and many companies are concerned with these things. And they're quite right, because very often we buy devices that we think are safe, but they're not that safe. And there are many backdoors there, such as this camera, or this German steel factory, where there was a disaster. They controlled remotely the material refrigeration, and they needed to discard all that material because there was a problem with it. And there are many more things happening. Sometimes it used to be far away from us, such as police cameras, routers, but eventually we will all have this in our homes. We'll even have connected toys that already exist and already have security problems that have been found, such as this teddy bear, with which our kids can leave messages, we can listen to them, and there was some sort of open door there for anyone to listen to those messages. So there will be many problems there that we'll need to solve. In reality, it may be difficult to find all these security problems, but I don't know whether you've heard of this website, Shodan. Everyone knows this in the first few rows, and here you can pretty much find anything that you may have in any device you may own that is connected to the internet. So it's very easy to find all those systems with open backdoors and default passwords. For example, Carnegie Mellon did some research and realized that attacks are increasingly complex and at a larger scale. At some point we'll have 20 billion devices connected, as we mentioned. The knowledge we need to work with those devices is lower. There are many tools nowadays to find those security holes and to find software that we can download from anywhere, such as GitHub, to have access to those devices. Look at what happened with Mirai. You went into many IoT systems that had default passwords, and there was a big problem there. It looked like the internet had collapsed because we couldn't have access to it. So we need to solve all that somehow. We need tools that give us the security we need. But who should we be afraid of? Who should we fear? Until recently, we knew that to protect our systems, we kind of knew the profile of people who would try to attack our systems. And we knew that those people had certain knowledge and that we needed to protect all our systems in a certain way. Nowadays, however, there are things such as this one happening. And simply while you sleep, they get your fingerprint to buy Pokemons at a store, or maybe you are watching TV and Alexa just buys things on its own. Because on the telly they were talking about a problem on the device, and the device heard its own name on TV. So why is this all happening? This is all happening because we have killed the third rule we have for system security, which says that we need to protect the physical space where those systems are. We need to protect it somehow. In an office, in a data center, we may have that under control, but nowadays there are many devices in our cars, in our lifts or elevators, on the street. We wear them. So the whole panorama has changed completely. And the way in which we use these devices has changed radically. So we need new security mechanisms and new things to tackle that problem. Believe it or not, I'm bringing some examples here. And since I work in IoT, I've brought many devices. Here I have an Inter-Edison with a Yocto. I have a little plate. I have a Raspberry Pi. I think that you all know those devices. So I can connect to the Inter-Edison through the serial port. Usually we connect through SSH, through the internet, we look for the default password. But if eventually you can have access physically to the device, you can connect to it through the serial port and do whatever you want. In theory, it also needs to be protected. But very often we have those devices in a local network, and we may think that it's not so important to protect it. So I have a few examples here. I'm going to look at the IP I have. I'm going to copy it. Okay. I have a little service here for Node-RED, which is a software that was created initially at IBM, and they had open source, and this is really useful to do our Internet of Things prototypes and connect our sensors. You don't need to program much, just a few things on JavaScript, and you do everything through a little portal here. I think the IP has not changed. 1880. Okay, so here's my Node-RED portal when I can plug my devices and my sensors. And here I have a temperature sensor. I can do a certain treatment on it and connect it. And here I have a connection to Azure IoT Hub, which is a service that allows us to collect all the telemetry of those devices in large amounts. We can actually input millions of events per second of millions of devices that we may have scattered around the world. But to connect to this service, we need a connection stream with its own security code. And here's our connection stream with our security code. So to steal that, first of all, I might need to find out the system credentials. And I might need to have access to this portal here. And if I manage to have access to the system, it's as simple as this. You just go to a little folder here. Off we go. We open the flow editor, and here are the credentials. So the Node-RED developers have been kind enough to cipher those credentials that I have there. They are coded, and it's much more difficult to steal. In the case of Intel-Edison, since having access to Intel-Edison physically is more difficult, it couldn't be done. But with the Raspberry Pi, as you know, the Raspberry Pi works with a small SD card. So this SD card, if eventually you can have access to the device, you can get the SD card, put it in your device, and read everything that is there. So what can we do with that? I'm going to put it here. It finds the card. Since this SD belongs to a Linux system that I have in a Raspberry Pi, I'm going to get the Linux reader. Now it's reading the card. And here I can go to the home. And and there's nothing coded or ciphered here in this card. So I go to Node-RED, I can see the credentials here, they're still ciphered, but since they haven't been ciphered with a certificate from the machine, I can save them on my local machine. And what can I do? Well, on my local machine here, I can do another one. I open another node and I go to the folder where I have it, which is test node. And here are all these files from the node I had in that Raspberry Pi. And here I'm going to open the help because I never remember the command line. So Node-RED, I could get the settings file, which is settings.js. I can get the user dir, this one here, and the flows file, which is this one here. So here I'm starting a Node-RED server, just like the one that I had in that Raspberry Pi that for some reason I managed to have access to. And now my local server, if I go here to localhost 1880, I have a flow that I have in that Raspberry, plus I have direct access to the connection stream. And that connection stream was a bit protected, but not much. So here there's quite a serious problem. I did this with Linux, but I could have done it with Windows. We have Windows 10 OT core for Raspberry Pi, and I could have done the same thing. I can actually put a Windows SD card and start to see all this. Okay, let's go back to the presentation. So what do you think of this? So what's happening here? As I mentioned, eventually the security part in IoT is much more complex. We can have physical access to these devices, and nobody will prevent that if we have a temperature gauge, someone with a lighter will come and get close to that temperature gauge. We need to solve things that before we didn't need to solve. And these are the problems we'll now have with the users. But the attack surface from IoT systems, even though the systems may be smaller and cheaper, and for 30 euros you have a full IoT system, in fact it doesn't mean that the attack surface is smaller. In fact it's much bigger because we're talking about a much bigger scale. And all this happens because eventually the IoT devices are breaking that barrier between the physical world and the virtual world. So we're having direct access to the real world, in fact. And we're not very used to this, at least in IT and development, we're not very used to doing all this. The people who are really used to doing all this are the operations engineers. In operations, they've always had to fight with these things. Vending machines that you shouldn't be able to open and those things. So the ops people know about that. And eventually the only solution will be to collaborate with the ops people, something new, and think of them when it comes to developing those solutions. The solutions we develop need to service the operations somehow, so they may control much better what's happening with all those devices. So from the engineering perspective, we have a little scheme here. You may check our documents regarding a typical scheme of an IoT typical solution. On the one hand, we have devices and then the cloud. So what happens here? If we try to do a stride model and look at the vulnerabilities, on the cloud side, this is under control, and we've seen many talks in the last few days regarding the problems that exist and how to solve them. Usually, however, we don't have that much experience on this side here, on this part here, regarding how to edit and how to get people to make physical damage to those devices or have access to them if they are scattered around the world. So we do need to find some way of doing this. Besides, there are some problems that we hadn't thought of. For example, when those devices are installed, but if you buy a washing machine, a fridge, or some other device, you do not expect to change it after 2 years because there are no firmware updates for that fridge. So what happens with all that? Who will come to repair the fridge? Whether the firmware come that fridge or that smart TV has, or any other device for that sake. What did the person do when they repair that device? There's a case of a Spanish city where they're changing all the traffic lights. And what happens with traffic lights nowadays? Well, since these are modern 21st century traffic lights, they are smart traffic lights. They're connected to the web. Every set of traffic lights has their own router and IoT systems, and the company that installs them is the usual electricity company that does the installations for that municipality, but they haven't trained their technicians to change the default passwords of those traffic lights. So now we can go to Shadon, look for those traffic lights and change them. And what happens with that? Well, eventually, the security problem there is a physical one. You can actually cause casualties and create many problems with this type of device. Just imagine that all of a sudden you're going up in an elevator and that elevator stops, or that the robot that is performing surgery on you needs to be updated in that process. These are things that we need to think of that we haven't thought of so far. We need to find ways of managing all that. And in fact, we do have cases such as this one that happened 3 years ago. The MIT decided to have a hackathon with the 20 most common smart home devices to find security flaws in them. In the first 3 hours, 5 of them were totally open with usual security holes. So we need to find many ways to avoid all that and minimize all those risks. One of the ways to do that is to manage well all the firmware from the very beginning, from the manufacturing of that device. How do we manage the firmware? And how do we manage the whole life cycle of those devices so there are no security holes in between? How do we control every step for every person that goes through that device? Because it goes from the manufacturer to the distributor, then to the installer, the integrator, the final customer, and it goes through many hands. Then we need to repair them, maintain them, and manage all these things. At Microsoft, we were really concerned with this, and about 2 years ago we launched a Windows 10 version specific for IoT. We had quite a bit of experience in embedded systems, and we applied all that experience to all the new systems that we're now launching. So if you're used to developing Microsoft technology, you'll be much more productive. But we have a full set of things that will help us in all these gray areas that we now have, mainly tampering and resisting changes in the device firmware, the operating system, and even the applications themselves. And this operating system is designed to be well connected. It connects really well to Azure. We have quite a few tools, in fact, to interoperate with the cloud in a much safer way and be able to resist all that. So in the IoT world, we have 3 slightly different systems We begin with a Windows 10 IoT core, which is just a reduced version of Windows that shares the same core with all the Windows systems we have from Windows 10. So it shares all the security features, and then we can keep growing. And the applications we do in a device as small as a Raspberry Pi, that application may be used for any other system. Even someday we may have it in an industrial large-scale computer, that application will work as well and have the same security features shared with the whole operating system. And one of the most important features is the coding or ciphering of all the data in the device. We've seen how a non-ciphered SD card, you can pretty much get anything out of it. So with BitLocker you can cipher that SD card, and to do so the device needs to have a TPM module to safely store those security codes. And some manufacturers are now developing devices such as Minobo Plus or Dragon Board that have those devices, and other manufacturers such as Simium are creating some modules such as for Raspberry Pi, so that we can have a TPM within the Raspberry Pi, so that not only can we cipher the drive but also store the security codes that we use to connect to our systems. So what happens if in that kind of device we put the keys and the codes that we use for our storage system, or the codes we use for sending our messages? Here we might be using and opening a massive door to anyone who wants to have access to the device. And whenever we have physical access to the device, it's just a matter of time for someone to extract that information. Therefore, we need some sort of hardware system to store all that data. Besides, the Windows 10 system is prepared to install applications from an application store. They're signed, no one modified them along the way, and within that IoT plate we can just execute the applications we choose that are duly signed. We just need to change a little flag in the system so that we can make sure that that device, the fridge, the elevator, whatever, no one's installing undue applications there. And then the updates. We need to be able to update those applications because there will be new security loopholes. And which of you has updated your fridge firmware recently? And who thinks that when buying a fridge or any other device, we're going to have firmware updates for the next 5, 10 or 15 years of that device's life cycle? That shouldn't happen. Look at this. All of a sudden my car key is not safe and anyone can open it. That needs to be updatable in the most automated way possible. In the case of a company, we may have an IT department that deals with the updates that system has. So we may have someone like Juanito who comes to Crichton Night and tell us about the problems we have, but what happens in our homes? What happens in the kitchen robot that downloads recipes from the internet? What happens with that?
Actualizar.
So how many times are we going to update that device? We need it to be updatable in an automatic way, and that's why Windows comes with this updating system, and it's been there for many years. And as I've said early on, we're going to have we're going to need a system where we keep all of those things. I'm going to make another small demo of how to store the keys and how the system works. If you can please connect the Raspberry now. There's an application there now. I'm going to stop it. This application. This is a sensor for temperature, humidity, accelerometer, and with this sensor, as soon as I approach my finger, you can see that the temperature goes up to 30 degrees. And so it's claiming I'm half dead already. And if I breathe on it, the humidity will increase. So you see how unreliable a sensor can be. It may not give us the right reading. So I have this small device that I've done with this little front end, and I can, with the mouse, I have a check here, and I can send all of this information to the cloud. So these data are being uploaded in the cloud, and if I get here, as soon as this starts, we will be able to see how the sensor is reacting and how we are sending all of that information in real time. So there it is. At some point, we should start visualizing information. But anyway, what matters is that these applications, because this is a Raspberry Pi, it doesn't necessarily have a user interface. And this application, it's there, and the connection still in it's within a folder for the application to access it, and then it has a number of security systems. The information is ciphered, and but doing the math in the middle of what this device is actually going to be very simple. So I have a portal here where I can manage everything that happens within this device. I can see the devices that are connected, whether I have a Bluetooth device, and here I can see the one I have over here. I can see all of your mobiles over here. You have to disconnect Bluetooth when you're away. And what have we got here? We have the TPM configuration. I don't have the module, software module. You should do that in production, but just to develop the application here. What I can do here is I go to another logical device for you to see it. I can introduce here. I'd have to click here. And I introduce a host name for a device. So I go to my portal. And here I have all my devices, the ones that are in my OT hub. IoT Hub has a special feature, and that is that each one of the devices has to be registered within the system, so that I can increase the security of the system. It's not to have a single key where all devices can use the same key to connect to the service, but each one of these devices is going to have a unique key to do the hash that identifies all the information that goes through that. So I have device connection string that I can copy, and in the portal you can see that the information comes up. If I touch at the center, you see there's a quick reaction. So I come here to the TPM configuration, and we have to configure the host name. The device ID. And the key. So all of these values I store I save them. And having done that, by code, I can ask TPM to generate this connection string. And in this field over here, this is the time value. So this string is going to be valid for an hour. I can define how long I want the string to be valid, just in case somebody wants to steal it. But the connection string doesn't need to be stored with my application in any folder for applications. It is directly stored for TPM, and I will ask for the next connection, and that's it. I don't have time to show it right now, but in very few lines, just with 2-line codes, I can access directly those values. So I don't need to save them here. Okay. You can remove the image there. So you've seen the device. This will work with the Linux operating system. It's a bit more complex, but it can certainly be done. And I've been able to do all of that also because I'm connected to the IoT Hub, which is the service that allows us to send all of the data, all of the readings from these devices in a secure way. So each time you generate a key, the key has a limited time. You can renew those keys, and it's not only that, but communication does not start from the server, but it starts always from the device. That is, from the very Raspberry Pi as soon as you connect it. It's the machine itself that does the connection against IoT Hub, and that opens the communication with a typical communications protocol, etc. So it is protected, and we can have a bidirectional communication with the device, but without having a specific port, so nobody else does access. So once we have all of the devices, we also need to give the people in operations some tools to be able to do the management of the whole life cycle of the device. That is, to plan how those devices are going to distribute it. But we may be talking about thousands of or millions of devices for the same company, how to do authentication, how to do provisioning, and above all, how to configure those devices. When we have 1 million devices distributed throughout the world, how do we send a new value for the configuration, or how do we update all of those devices? Because we would probably need to do an update, or the operating system, our application, whatever. So how can we manage all of that without having to build the whole system ourselves? And we can do that with IoT Hub, because beyond having the endpoints over here, from sending and reception of telemetrics, and we have the telemetrics that we are picking up from all the sensors, and IoT Hub is collecting telemetrics from from the device itself. It will know when it's on, when was the last time that it was on, when was the last time it received a message and answered that message. All of that information will be stored in IoT Hub. And we also have endpoints such as tweets and method endpoints, which are the ones that will allow us to manage those devices. So tweets are just a representation of each one of those devices in the cloud, with a number of features that we will see next. We have that representation of the device with properties just as we want them to have in the ones that are already registered. And why do we do that? Because when a device boots up, the first thing it does is to report which are the values that have already been applied to its configuration. So we will be able to know that and to register that. And at some point from the cloud, we'll be able to say, now, you need to have this new configuration, and we can tell the configuration which is the device, which is the configuration that it should have, and that will be maintained in cloud. So each time the device is re-initiated, it can read those values for its configuration so that we can manage that. And we have a lot of metadata that we will also be able to apply in those virtual devices that we have in the cloud. And what's that for? Well, in order to be able to make consultations later on to define where the device has been installed. For instance, give me make a query of all the devices in Madrid, of the devices that have a specific operating system. And what's interesting about all this is that, for instance, the desired properties, that information can only come in one direction from IoT hub towards the device, whereas the report of properties such as they have been saved in that device can only go in the direction from the device to the cloud, so nobody can change those values halfway through. And then we have methods so that we can obtain an immediate reaction of the device and say you have to update the operating system right now, and to define a method so that it can do that. And it's not only that, the device itself can report what methods it has. The device will say, I can update my operating system. Some will not be able to do so. There are even devices that do not have an operating system, or because they have to be manually managed. And in order to manage all of that, because this applies to each one of the devices, and in order to manage a large volume of devices, we have tools within IoT Hub to be able to manage that. So out of the 100% of devices, I'm going to take the first 20. I'm going to update that 20%, and if everything goes well, you check, you make sure everything went well, and then you execute this configuration within the other 80%. So for all of that, we'll be able to manage directly from the tool, and we will be able to make a number of consultations, as I was saying, to say what's the situation of those devices, which are the values applied, etc. So I've made a short command line, and everything that I'm showing, it's in my hub, and if you are interested, I can share it with you through Twitter. But I've made a little script here in Node to be able to do those things. For instance, what I'm going to do here is to tell my application about a background color so that it will look different. And then I have a select here, where it only looks for the device ID and tells me the properties. Doing that is as simple as saying I want to do a get twin. You get the twin of the device, and then you send a patch of the labels, and you have them there saved. And everything we're doing here, we wouldn't be doing from the device. We would actually be doing it from an application of our own that manages those devices in the cloud, because in order to do this, we need the administration credential for that system, for that IoT hub. And here we just send an update, both of the tags to tell them the region and of the desired properties, when in this case is only going to be the background. So I will open. Let me stop the Raspberry first. I'm going to open this application, which is the one I had in the Raspberry. I had a Windows 10 there, and I have the same here, so I can do this. So what I'm going to do is do a ZDG color, and instead of FF00 we're going to have a funnier color. Do you know the color Favela? I'm going to tell it to do this, and then I am allocating a query and identify in this device the background, the existing background, and of the devices that are only within Madrid. So I've sent the color, and at some point I have a connectivity problem here, and because I am there it is. The connection wasn't working, so I'll change the color now. And if when the system started up had tried to read that value of the desired properties, and it has already applied it, and if I boot the application, you see that first it's in white, and then as soon as it connects and reads the values, then it applies them. So let's introduce Servera again. So it's changed, and so far it's telling us that the color is red. But we have two devices, which is not a red device with no background property, but then I have another one when I do have a background property, and then it will receive the updates in a few seconds. Okay? Okay, this is for device management. And then before we finish, we've seen what we have so far. We have systems that are connected to a cloud or to some of our data centers. As I've told you earlier on, we didn't used to have anything connected, and now everything is connected. But how is it going to be in the future? We're not going to have a central server where we have all of that, but the way things look to experts, we're going to be seeing many devices that will be connected with each other. And how are we going to certify that all of those connections are good and the data that we're getting from one device or the other one is good? We're going to need another way of managing security and managing all of those devices. And one of the things we're seeing is that blockchain is being used not only for online payments, but also for other types of operations where we need a different level of security. So probably in a few years' time, we will see how blockchain will be applied to this type of devices. And that will generate for us new paradigms. We're going to have to change the way in which we manage the security of all of those devices, but let's hope it will be a lot better. So to summarize, the issue of managing security in IoT, it's a lot more complex than we used to think, because at the end of the day, we are we know that there's always going to be a user, and because it's a large-scale deployment, somebody is going to find a security hole that we did not expect, and often we will be talking about problems with the physical device, and that's why we need to find a way as engineers to deal with the security of devices. Sorry, I've taken a bit more time than planned, but I think I have 1 minute left for questions. It's a great talk. Thanks for what you did earlier. And I have a question. Azure has the operation management for it took a portal later on where it connects the whole inside part of Azure for all those problems that you've mentioned. Is IoT also integrated there? Partly so. There's part that isn't, for instance, Windows 10 and IoT Core. There are things that cannot be introduced directly, but there's a lot of sort of integrated part. In fact, it's one of the ways of managing that. And a final question, the inside part, the IPA, Microsoft, does it have endpoint for you to be able to consult IoT issues? I don't know that. We'll have to ask. In Azure, the inside part, you can generate user reports for IoT. Well, if you're programming with Windows 10 and IoT Core, you can add a library to send all of that information to the inside. Thank you. Any other questions? Okay, thanks very much.
La charla que hay en la sala 25.
The talk in room 25 is also going to be shown here, so you don't have to stand up.
Bueno, lo que estáis viendo ahí es
So there you can see Be Real Challenge. This is a company project